So when we are doing prime factorization, we have to know what is the prime numbers mean. Prime numbers are the numbers which is more than 1 and that it can only divide by itself. So it means 2 is the prime number, 3 is the prime number, 5 is the prime number, not 6 because 6 can be divided by 2 or 3, but 7 is the prime number. So these are the numbers only can be divided by 1 and by itself, and which is more than 1. So this is the definition of the prime numbers. And any numbers have, we can make prime factorization. What does it mean? If we have the number like 12, that's what we started with, 12 and 16, 12. If you make a prime number factorization, it means we know that we can divide by 2. So 2 times, we are making times, so 2 times 6 is 12. Then we are breaking again, so this is already prime number. We can make it like a round, so it's easy to follow. And the next one, 6 again can break up by 2 times 3. Now you can see, so this 2 times 3 is also 6, and 2 is prime number, 3 is prime number, 2 is prime number. So we can break the 12 by using the prime factorization. So we can just write, okay, our 12 is basically 2 times 3, and this is prime factorizing. And then if you do 16, we can break like, okay, 2 times 8, and 2 is already prime numbers. Then 8 you can break like, okay, 2 times 2, this, oh sorry, 2 times 4, you can just make it 4. And then 4 you can break, oh sorry, 4 is not prime number because we can break 4 by 2, 2, 2, okay. So we can just break it like 2 times 2. So I'm just making the round circle for the prime number. So you can see that we can break that 16 in terms of the prime factorizing, which is 2 times 2 times 2 times 2. Okay. Now, how to find out that LCM? So when you do the prime factorizing, you can get LCM and HCF. So if you do LCM and HCF. Okay, HCF is easy. You can just look at here, highest common factor. So you are looking for the, what is the maximum common factor in here and here. You can see we have 1, 2. So if I just want to cross and show you, or you can just mark like that. Okay, 1, 2, 1, 2 here. There is another 2 also here. There is another 2 here. But there is a 3, but there is no more 3 here. Okay, so this is the maximum thing in common between these two numbers. So 2 and 2, so 2 and 2, these are the common thing, right? So it means 2 times 2 is the common for these two numbers. Because these 2 times 2, sometimes is they are showing as a cross, like we are crossing this, taking 1, 2, then another 2 cross, taking another 2. So we are just looking what is the common that both can contribute. So 16 can contribute 4 because they have that 2 times 2 and they have also 2 times 2. So both can contribute the same thing, or that 2 times 2 is 4. So 16 can be divided by 4, 12 also can be divided by 4. Now, so this is HCF. So I mean 4 is our HCF, and I think we did already before that our the 4 is the highest common factor for these two numbers. So we are getting exactly the same thing. And what is the least common multiples? In order to get least common multiples, the strategy is you just write down this maybe in terms of, okay, 2 to the power 2 times 3. You can just make an index form, and here you can, this is, you can write down 2 to the power 4 because 2 times is 2 to the power 4. So when you are dealing with the least common multiples, you are writing all these factors, different factors, but when it's the same one, just 2 and 2, the prime number is 2 and 2, we are taking the highest index one. So it's a 2 to the maximum index one. So it's 2 to the power 2, 2 to the power 4. So we are just taking 2 to the power 4. Then multiply, we have 3. We have to take all the factors, as I said. For the least common multiples, we have to take all the factors. If there are something similar, then we have just taken the highest index. So if it is 2 to the power 2, 2 to the power 4, we have to take 2 to the power 4. 3 to the power 1, 3 to the power 0, there is no 3 here, so it means we have to take 3 to the power 1 or maybe 3. So now if you do the calculation, and you can see it's a 2 to the power 4 means 16, and 3 times 16 is 48. And if you look back to our original answer, or before the one that I showed you, 48 was our least common multiples for the number of 12 and 16. But this process is easy. You just do the prime factorizing and just find out the least common multiples and HCF at the same time. There are some way that they are doing the highest common factor by doing the Venn diagram, but I realize the students get confused when there are 3 or more numbers given. So I am not going to advise you to follow that Venn diagram in this case. Just do the prime factorizing, and common factor you are just checking what is common and taking out, and then for the least common multiples just go with the index system. So I am like, for example, if I add one more number here, 12, 16, and then I am just adding 18 in here, then what would be the least common multiples and highest common factor? What I am doing here, I am just doing a prime factorizing for the number 18. And as you know that what we are doing, we are just dividing by 2, which is 9. The 9 can be divided by 3, which is 3, and these all are prime numbers. So if I just write down in here, then 18 is basically, I'm just writing in terms of the prime factorizing, 2 times 3 times 3, for example, or you can just even write down 3 times 3 square, that's fine, 2 times 3 square. Okay, so yeah, definitely 3 times 3 is 9, 9 times 2 is 18. All good. And if you want to write down as a like a index form, then 2 times 3 to the power 2 times 3 square. So our HCF for these 3 numbers would be, you can just say what is the common for all these numbers. So 2, 2, 2. So we can take 2 because all these 3 numbers can share 2. But you have 2 here, we have 2 here, but there is no 2 here. Okay, we have 3 here, we have no 3 here, but even though we have 3 here, so we can't take 3 as a common factor. So our highest common factor for these 3 number will be 2. What is the least common multiples? Least common multiples. So our least common multiples would be, you can see 2, we have 2. What is the maximum index for 2? 2 to the power 2, 2 to the power 4, 2 to the power 1, or there is no like index 1. So maximum index would be 4, 2 to the power 4. And then for 3, what is the maximum index? So 3, and there is no 3, there is a 3 to the power 2. So we have to go for 3 to the power 2. Now if we expand it, 2 to the power 4 is means 16 times 3 square means 9, which is 4, 4. So it means 144 is the least common multiples of these 3 numbers. Now imagine then, if you use that first method that we used, how to find out the multiples of 12 and 16, if you do that 3 numbers 18, you have to go so many multiples to reach at least until 144, which is time consuming, and you have to do lots of calculation for that. But doing this method is really helpful. So what we need to do, we need to do the prime number factorizing, and each number you can factorize by prime number factorization, and then we need to write down the numbers with the prime factors and index form. If you have like 2, 3 here, the 3 to the power 2, and then we are just trying to check for the highest common multiples. We are trying to check what the number all these numbers can, or what are the factors that all these numbers can contribute. So we can see 2, 2, 2 is the common factor for all these 3. If there are more, then we have to write down times of this number. And then for least common multiples, we are just taking all the factors. If we have a 2, 3, 5 in there, we have to take all these. But whenever you have 2 in the 2 different places, you have to go always the highest index or largest index. So you can try probably one more question by yourself and see what is by using this method. Maybe 24, 36 and 50. So you guys can try to do the prime number factorizing for 24, 36 and 50 and find out the least common multiples and highest common factor. Thanks for watching, and if you'd like to see more up-to-date videos, please subscribe the channel.